Welcome to this deep dive into one of the most confusing yet fundamental concepts in statistics, Bessel's correction. Why do we divide by n-1 when calculating sample variance instead of just n? Today we will demystify this mathematical magic trick and understand why it's essential for accurate data science. To start, we must distinguish between a population and a sample. A population is the entire group we want to draw conclusions about, like every server in a global data center or every citizen in a country. A sample is a specific group that you collect data from. In practice, we rarely have access to the whole population, so we use samples to estimate reality. Variance measures how spread out our data is. For a population, the formula is intuitive. We take the sum of the squared differences from the mean and divide by n, the total number of items. This gives us the average squared distance from the center. It's a perfect representation because we have all the data points. However, when we take a sample, something strange happens. If we use the same formula, dividing by n, we consistently underestimate the true spread of the population. This is called bias. The sample mean is usually closer to the sample data points than the true population mean is, making the data look more clustered than it actually is. Think of it this way. The sample mean is calculated from the sample itself. Because of this, the sample data points will naturally be closer to their own mean than they would be to a population mean they don't even know exists. Dividing by n fails to account for this lost variability. This leads us to the concept of degrees of freedom. Imagine you have three numbers that must average to 10. You can pick any value for the first two, say 8 and 12, but the third number must be 10 to keep the average. In a sample of size n, only n-1 values are free to vary once the mean is fixed. We lose 1 degree of freedom because we use the sample data to estimate the mean first. Let's see this in action with a simulation. If we repeatedly sample from a population and calculate variance using n, the average of those variances will be lower than the true population variance. By dividing by n-1, we mathematically stretch the result just enough to correct this bias. This is Bessel's correction. In the real world, companies like Amazon or Google use this every day. When testing the latency of a few thousand requests to estimate the behavior of billions, using n-1 ensures that they don't underestimate the risk of slowdowns. It provides a more conservative and therefore safer estimate of volatility. To summarize, use n when you have the whole world in your hands. Use n-1 when you are looking at a small window of that world and trying to guess what the rest looks like. It is the difference between describing what you see and predicting what you don't. Thank you for joining this exploration of statistical fundamentals. Mastering these small details is what separates a data analyst from a true data scientist. Keep exploring, and remember, statistics is the art of measuring uncertainty. References: 1. Casella, G. and Berger, L. Statistical Inference. 2. Devore, J. L. Probability and Statistics for Engineering and the Sciences. 3. Kudrati, D. N. Basic Econometrics.